Hi, the section 4G, the annuity with varying interest. So we think about the present value and the accumulated value of the usual annuity immediate with $1 payments when interest rate is changing over time. So far, the annual effective interest is fixed at I, and I is a constant, but here the A of t is equal to 1 plus 0.01, the t square. So that means, okay, so A0 is normalized as 1, but the A1 is equal to 1.01, A2 is equal to 1.04, and A3 is equal to the 1.09, and so on. So in the first year, interest is 1%. The second year, maybe slightly less than 3%, and third year, slightly less than 5%. So interest rate changes over time. Okay, so we think about the time diagram. We have 5 years, so t is equal to 0 here, and 1, 2, 3, 4, 5. And the present value is here. And the accumulated value also we have to calculate later here. And we have $1 payment at 1, and the $1 here, $1 here. So just for illustration purpose, we put $1 in this way. So $1 payment 5 times. Then, okay, so we want to calculate the present value. So what's the present value of $1 at time 1? The present value is 1 over A of 1, right? Because the A of 0 at time 0 is worth A of 1 at time 1. So that means that, okay, so A of 0 is 1. So we have to divide the amount by A1 to equate the value. So this $1 becomes A1. So that means the 1 over A of $1 becomes $1 after a year. So in the same way, the $1 at time 2, this is worth 1 over A of 2 at time 0. Right, because the A of not, the $1 becomes A of the $2 after 2 years. So that means the present value of $1 is 1 over the A of 2. So we can do the same thing for this one and this one and this one. So the final one is equal to 1 over A5, A of 5. So that means the present value is equal to the 1 over A of 1 plus 1 over A of 2 plus 1 over A of 3 plus 1 over A of 4 plus 1 over A of 5. So we don't have any magic way to calculate this immediately, but you can just plug in all numbers, then you can get the answer. So this becomes 4.53. So the present value is $5.53. Okay, so let me see if this is appropriate. We have, okay, so A1, A2, A3, A4, and A5. So interest rate is, okay, so first year 1% approximately, then 3%, 5%, maybe 7% and 9%. So on average, this maybe may have the interest of 5%, and the amount is in the account for 3 years on average. So 5%, 3 years. So that is the 15% maybe. So we have the 15% discount, and yeah, that is a little less than the $4.5, probably about 5%, 15% of $5 is 75 cents, so 4.25. That's the yeah, but still it's a kind of reasonable answer. So it's hard to see the approximate amount because the interest rate is changing over time. Okay, so how about accumulated value? Accumulated value of this cash flow is what? This is not difficult once you got present value because the $1 becomes the A of 5. So that means the accumulated value is equal to A of 5 times PV. So this is equal to the 1.25 times the 4.53. So this becomes 5.66. So it's more than $5. Okay, so in general, the interest rate is changing with the force of interest delta sub t. So if delta sub t is given, then you can calculate AT is equal to exponential of integral the 0 to t, the delta r dr. So if you integrate this delta r function, then you can get A of t. Once you get A of t, you can calculate A of 1, A of 2, A of 3, A of 4, A of 5. So you can calculate one by one. And we don't have any shortcut to calculate this summation at once.